Hello everyone. Let me explain you rectifier and its type. Rectifier. What does this term rectifier means? This is a device. Okay, this is a device which converts AC current, okay, or voltage to DC. We have many instruments or devices in at home like charger and all. Those all are rectifiers. What it does, it changes direct current. No, it changes alternating current to direct current. Okay, so uh, how it works? Actually, it works with the help of PN junction diode. This is P, this is N. And what is the principle of this PN junction diode? When P end is connected to high potential and N terminal is connected to low potential, then it works as a forward bias. Forward biased, and also you can say the resistance is almost zero. Resistance is low or almost zero. And in other way, when we exchange this, like we'll put here low potential and here high potential, then what happens? Then it acts as a reverse biased. Here what happens? Here the resistance is uh, infinity. Got it, na? So that's why it acts as an open circuit. It acts as an open circuit. Clear? Okay. Let me go forward. Like a rectifier, we have two types of rectifier. One is half wave rectifier and the other is full wave rectifier. Let me draw the diagram and let me explain you how this half wave rectifier works and then the full wave rectifier. See, first of all, this is input and this is AC. What is this? This is transformer. You know what is transformer? Transformer is is what? It converts high voltage to low voltage. Not only high voltage to low voltage, but also low voltage to high voltage. There are two types of transformer. When high voltage converts to low voltage, we call it step down transformer. And in the reverse way, when it converts low voltage to high voltage, okay, then we call it step up transformer. Clear? Here what you will use? We will use step down transformer because AC we have how much AC at home? We have 220 volt. We use 220 volt, and the frequency of this AC in India is 50 hertz, whereas the frequency of DC is 0 hertz. Frequency means what? The cycle per second. So here this 220 volt has been reduced. So we'll use here step down transformer. Here we have what insulating cords. Okay, let me draw this. So here AC, here transformer, and then we'll have here PN junction. We'll have here load resistance. Okay, load resistance, and then we'll get here output. Here it's this is input, this is primary part, and this is secondary part. Okay, so we can consider this as P2, this is P1, here S2, here S1, yes, S1, this is P, this is N, and anything else? No. Okay. Oh, now see, AC we have sinusoidal waveform. hmm. uh, Let me draw here. AC will have sinusoidal waveform. This is input, okay, input, and output, the wavefront what we'll get, we'll note it down here. Okay, suppose these are the terminals. See here, when this is positive, okay, when the positive cycle is here, then this P1 is negative. Let me draw with red pen. P1 is negative and P2 is positive, okay, for the positive cycle. And due to mutual induction, S2 becomes negative and S1 becomes positive due to mutual induction. Okay, so when this P terminal, this PN junction, P terminal is connected to positive, then obviously this will act as a forward bias. So forward bias, that means resistance zero. So resistance zero means this will conduct, and thus will get a output here. Here also it's negative, so negative, and here positive, will get an output here. So we can denote this cycle as this. Look, DC is not constant. DC also varies, but the difference is that DC, it only travels in one direction. Okay, clear na? AC, it changes its direction, but DC does not change its direction. Clear? Okay. Next, for the negative cycle, for this one, for this negative cycle, here P1 will be positive. So if P1 is positive, due to mutual induction, this will be negative, and here this is negative, this will be positive. So you see here, now P terminal acts is connected to the negative terminal. Since P terminal is connected to the negative terminal, so it will act as a reverse bias. PN junction will act as a reverse bias, so resistance will be high, so you won't get any output here. Clear? You won't, this will act as an open circuit, so your output won't be there, so this will be this way. Okay, and then again for the next one, next positive half cycle, again this P1 is negative, you'll get here positive, this is positive, you'll get here negative due to mutual induction. So P is connected to positive terminal, so forward bias, no resistance, and then conduction, conducting what path will take place. Okay, so that's why here again you'll get one cycle. Clear? So this way you can say that this is half wave rectifier. This is half wave rectifier. Clear? Half wave rectifier. What will be the output? Here you will get a positive half, and then you will not get anything, and then again you will get positive half cycle. Clear? So this is the way how half wave rectifier works. Now let us go for full wave rectifier. And what are the changes in full wave rectifier in this diagram? See, full wave rectifier, we will use two PN junction. Okay, in full wave rectifier we will use two PN junction, and the load will connect it here. Load resistance will connect here. Okay, we'll get output here. This is input, output, and rest all are same. Rest all are same. Okay, clear na? So see how it works. The input will be same, AC. Okay, AC, positive half cycle, negative half cycle, but the output which you will be getting here, output which you'll be getting here will be for first positive cycle. Okay. Hmm. Suppose this is diode 1, this is diode 2. Here first positive, so here this is negative, this is positive. So when negative, it will become positive due to mutual induction, and when positive, this will become negative due to mutual induction. So here positive terminal connected to PN junction, I mean to say uh, P portion. So this will act as a forward bias, and thus you'll get one reading here. But here this P junction is connected to the negative terminal. This will give high resistance, and thus you will not get here any what it called cycle. So here it will not produce any result. Okay, this is open circuit, and this is closed circuit. So here for D1 you will get one half cycle, positive half cycle. This is for D1. Okay, due to D1. And then next what you'll do, next here positive, this will be negative, and here negative, this will be positive. Now what happens, now this will behave as a reverse biased, and you'll have high resistance. So for this D1 you won't get any result, and for D2 this will behave as a forward bias, and for this you'll get one positive half cycle. So here you can also draw one positive half cycle. This is due to D2. Again for next, here minus, here plus, here plus, here minus, here you'll get positive half cycle because this is forward bias. Here this is negative in what a reverse bias, so you won't get here any cycle. So here for D1, due to D1, D1, D2, D1, D2. Okay, and the last topic, okay, of this rectifier is the efficiency of the rectifier. Efficiency of the rectifier. Look, what is the efficiency of full wave and half wave rectifier? How you'll find the efficiency? Efficiency, we consider it as eta. This is known as ETA. Eta. Efficiency, the formula is output and then input. Input what we gave? Input AC we gave. Output what we got? DC. Okay, into 100%. So for remember, for half wave rectifier, the efficiency is 40.6%, and for full wave rectifier your efficiency is double of this, that is 81.2%. Clear? So this you have to remember. Okay, so output DC power, and here also it's power. Thank you very much. This was the rectifier and its type.